All right, so the question we want to look at basically gives us this matrix and says, what values of H must we avoid in order to make sure that we have a consistent system? And so remember, an inconsistent system would have a reduced matrix that looked like this, and then something non-zero there. Doesn't really matter what's on this top row, because in that bottom row you have these two zeros and a non-zero term. So that's what we've got to avoid. We have to avoid wiping out all of one row. So we have to make sure that we choose H so that that doesn't happen. Well, let's keep that in the back of our mind, and let's just reduce this matrix, right? Now, so we know what we've got to do here to reduce this. We're going to go ahead and say, let's take -2 times row 1, add to row 2, replace row 2. So -2, -2h, 10, and then 2, -8, and 6. And when we add those, of course, we're going to get that right there. And that's going to be our new, let's put it right over here, row 2. Okay, so remember, we're trying to put this matrix in reduced form. So we now have our leading terms in each row. We want to now eliminate the 0 above this leading term. So we've got to figure out what we need to multiply these things by in order to eliminate them. So it looks like it could be kind of complicated, but we could always just play the game of saying, okay, let's take row 1 and hit it with a 2h minus or plus 8, and then we'll leave row, we'll take 2 and hit it with an h, and that'll become our new row 1. So row 1 multiplied by 2h plus 8 is a 2h plus 8, and then an h times 2h plus 8, and then a minus 5 times 2h plus 8. Looks kind of clunky, but it works. And then h times row 2 looks like this. H times -2h minus 8. And that negative in here could come out here right there, which is what we're going to need. And then finally, 16h. So if we add those, 2h plus 8, these two things are going to be 0. Check it out, verify it. And then finally, we need to add these two. Let's see, if we distribute the -5 through, it's going to be a -10h. Plus 16h is a 6h, and then I think a minus 40. Let's make that a 40. And so that's going to be, let's put it here, our new row 1. Row 2 is right here. Okay, so that is almost put into reduced form. We could divide this row by 2h plus 8 to get a 1 there, and divide this row by -2h minus 8 to get a 1 there. But we actually will be okay, because remember what our goal was. We cannot have this be a 0 and this be a 0, because if that's the case, then we've got an inconsistent system. Likewise, you cannot have this be a 0 and this be a 0. Well, we've already got zeros here. So basically what we have to do is we have to make sure that these two things aren't 0. And if you look at those, they're the same thing. They're just opposites of each other. So if we want to put that more explicitly, we would say something like this. Negative 2h minus 8 cannot equal 0. Otherwise, that gives you the zeros in the first two positions. So solve that for h, right? So you're going to move the 8 across. So it's a negative 2h equals 8. Divide by negative 2. H, let's see, leave that as a negative, or a not equals to. H cannot equal negative 4. As long as h is not negative 4, then this is not 0. But if h equals negative 4, this equals 0, and in fact this equals 0 as well. But really all that matters is that one of them equals 0. So there we go. We got to make sure that h, anything but negative 4 for h, gives us a consistent system. So there we go.